Look at the frame of this boda boda. It is supporting a heavy load of passengers, keeping them steady as they move through traffic. The frame's stability comes from the specific mathematical angles hidden within its construction. Mathematically, an angle is simply the space between two straight lines exactly where they meet. By understanding how these intersecting lines behave, builders can plan and design the physical structures of our world with precision. We can see the simplest version of this on a long, straight road. It creates a perfectly flat, horizontal surface to work from. If a path crosses that road, the two angles created will always add up to exactly 180 degrees. And when lines meet around a single central point, they form a complete circle, totaling 360 degrees. These measurements, 180 and 360, are the permanent rules that govern every flat surface we build on. These train tracks are parallel, meaning they stay the same distance apart and never meet. When a diagonal path cuts across them, which we call a transversal, it creates a specific pattern of angles. We trace a Z shape across the intersection for equal alternate angles. An F shape shows corresponding angles are equal as well. Finally, a C shape highlights co-interior angles inside the lines, which add up to 180 degrees. Recognizing this Z, F, and C code allows a builder to know the size of every corner in a structure without having to measure them one by one. You can see these principles in action on traditional village roofs. Their strength comes from the triangular wooden frames hidden beneath the thatch. Triangles are unique because their three interior angles will always add up to exactly 180 degrees, no matter how the triangle is shaped. To understand exactly why this is always true, we can take a simple paper triangle and carefully tear off all three of its corners. When you place those three torn corners side by side, their points meet to form a perfectly flat straight line. This locked 180-degree property is what makes the triangle structurally predictable and incredibly strong when it has to support a heavy roof. We can use what we know about triangles to calculate the inside space of larger shapes, like polygons with 5 or 6 sides. By drawing lines from one corner of a pentagon to the others, we see it holds 3 triangles. At 180 degrees each, that totals 540. The rule: subtract 2 from the number of sides and multiply by 180. This single formula allows an engineer to calculate the interior angles of any straight-sided shape imaginable. We can also look at the exterior angles created when we extend the lines of a shape outward. No matter how many sides a polygon has, its exterior angles will always fit together to form a perfect 360-degree circle. Because an interior angle and the one right outside it sit on a straight line, they always work together to maintain that 180-degree balance. From the parallel lines of a city street to the triangular trusses of a school roof, these rules are constantly at work. These geometric angles are the hidden architecture that allows us to design and build our world with confidence.